Okay, so let's begin. First things first, we would first understand what IP addresses are, right? If you are already knowing that there are two different classes of IP address, one is IPv4, another one is IPv6. What IPv4 stands for, it's IPv or IP version 4, and then came in IP version 6, where in IP version 4 we have got 4 octets, in IP version 6 we have got 6 octets. So what does octet means? It is a group of bits that would represent a specific section in your IP address. So let's say this is IP address that we have. I'm taking an example, okay? So this is 1.1.1.1. We already know that this would be IP address that would be representing some of the addresses on your network. Now that network which is there is falling in class A for now. I'll tell you what different classes are. Okay, can I get a quick confirmation from you guys that you are able to listen to me and also see the screen? You can type in your chat boxes. Anyone who is not able to listen? Okay, thanks for the feedback. Uh, there are a few people who are not able to hear me.
Hello.
Yes. Just give me a moment. I'm responding to these people. Okay, so I was talking of an IP address. This IP address that I'm talking of belongs to class A. Okay, it is decided from the octet levels, whatever octets are there. You guys, can you please unmute yourself so that we can go on disturbance free? All right. So in this IP address, there are 4 different octets. So 4 different octets are separated by the dots. The first octet is here on the first location, first position. So I'll mark them. This is the first octet. That's the second octet, the third, and the fourth octet. So these 4 octets are actually a group of 8 bits. And if it is a group of 8 bits, how many of them do you expect? Like how many systems do you expect would be present in that particular octet? So it is 2 raised to power 8, right? What's 2 raised to power 5? Okay, that's 32. You all know that. If you move one step further, it's 64, 7, 128, and 8 would give you 256. So the total number of systems or IP addresses that are available in the first octet or any octet is 2 raised to power 8. Okay, and we do -2 as in first, which is the IP address this, that means uh, it belongs to 1.0. Okay, it would be 1.1.1.0 in our case. It starts from 0 and it would extend till 255. Okay, so we are using 255 and 0 for reserved purposes, all right, for broadcasting and multicasting. So we don't provide these IP addresses to the machines. So none of the machines would be having these IP addresses. If you look closely, 255 is generally used for subnetting. Okay, generally used, and .0 is used for broadcasting the IP addresses, broadcasting the packets into the into the particular domain or in the network. So if you want to represent a network, we generally represent it with an IP address of 0. Okay, so the different classes of networks are like this. Class A, then there would be B, C, D, and E. So what is Class A? Class A is the one in which your host networks are one single octet. So the starting octet would be the would be regarded as the host network. Okay, so starting octet as in it would be the first one that I've written. The range of it is 1 to 126. Okay, here in class B, it ranges from 128 onwards to 191. Then in class C, we start with 192. So if you get an IP address which is starting with 192 series, or the IP address which is starting in 128 or 172 series, those two are different. Okay, so class C would be starting with 192 onwards to 2 to 3. If you must have seen an example like in your organization or so, the IP addresses that you generally use are of class C or class B. In bigger organizations, we get the IP addresses which begin with uh, 172, which is belonging to class B. Generally, we use it for class C. Even in my internal networks, I would be using class C as in my IP address. The reason why we use that is that we don't need those many systems to be present on a particular network. I'll talk of systems in a while. In class D, we have it starting from 2 to 4 to 239, and in class E, we have 240 onwards to 254. Again, 255 is not considered, and 0 is not considered to be the one. Class D and Class E are not used generally in public. Class D is used for multicasting. Class E is used for experimental purposes. It's used for research, not in normal life. So I was talking of the different network parts. Here in Class A, we have the first octet treated as network. So I'll call it as N, and rest of all of them are hosts. Okay, so the default subnet mask is this. Okay, so what is a subnet mask? Subnet mask is a group of bits that would identify the network part for you, not the host part. Okay, yeah, a good question here, Anil. That what is 127 used for them? Because we haven't mentioned 127. It's 1 to 126, 128 onwards. Where's 127 missing? 127 is a very specific IP address which is used for loopback purposes. You must have used this as localhost. Okay, so that belongs to the loopback category. Class 1 looks like this. What's in class 2? In class 2, we use two octets to be representing the networks, and the default subnet mask is 255.255.0.0. So the bit representation of this subnet mask looks like this. Subnet bits, they would look something like this. In class B, it would be 8 ones, again 8 ones, and all of the others would be 0. So whenever you perform an AND operation on your IP address and a subnet mask, then it provides you with the network part which is being used. So many networks you can have, and per network you could have so many hosts or you could have so many machines. So if I'm talking specifically of 192 series, which is a class C, Here this is class B. If I'm talking of class C, in class C we have three network parts. That means you could have 2 raised to power, I say 7, 8 plus 8 plus 8. Okay, those many networks, and the host part is 2 raised to power 8 minus 2 again. So the subnet mask here in class C is 255.255.255.0. 255 actually is a decimal representation of the bits when all of the bits are 1. Okay, when all of the bits are 1, it calculates to 255. So the subnet mask would be like all ones, all ones, all ones again, and 0 part at the last. So you have just one host part. How many hosts or how many machines can be there in one particular network? It is the number of zeros. So there are 8 zeros. So let's say 2 raised to power 8 minus 2, it calculates to 254 machines in class C per network. And the network can take multiple values. Per octet it can range from 1 to 254. Okay, so um, it depends, right? So here in this series 192 to 223, your IP addresses would range. I'm talking of class C very specifically. For class C, your IP address ranges would be from 192 onwards, starting with 1, and any IP address in this series would be 223 dot 254 dot anything dot anything. Okay, that's how the ranges goes. So the total number of systems which is calculated to be here in class C is somewhere close to 2 raised to power 21 minus 2. These are the number of networks which are available. The last star which I've denoted here is the number of hosts per network. So it would be 254 machines per network that I can place in that particular uh, class network. So what is a domain? Okay, what is a collision domain and what are the broadcast domains? Whenever I am giving an IP address, let's take a scenario. I'll give you a short scenario. I need a lab to be set up. The constraints are that there are two labs. I will call it as lab A and lab B. Both of these labs are having same series of IP address. So they would be using the IP addresses which are very common. So 192.168. Maybe they are using 50 series or so. Let's start with 0. Still 0 also works. 0.1 and 192.168.0 dot something. Now this something has to be calculated. I want lab A and lab B to be sharing the same IP address pool, but at the same time lab A people should not be able to connect to lab B. How do we achieve it? Well, in order to achieve that, let's look at the bitwise series. So this subnet mask which is having the first octet series to be 111, which is 255.255.255.0. 0 part represents the number of hosts. Well, but I want to split it across two different networks. So if you see that we have got 8 different bits as zeros. Out of these 8 different bits, if I can or I could just borrow one single bit for network purposes. So the starting bit, if I borrow it for network purposes, we can switch the status of it, right? It can be 0, it can be 1. If it is 0, it would belong to a separate network. If it belongs to 1, then it belongs to a separate network. So what I'll do is I will make it 1. So this is a subnet mask that helps me in splitting one single common network or homogeneous network into a group of 2. Now every network that we create with this particular subnet mask, which is having 1 borrowed from the host area, would be uh, having 2 raised to power 7 minus 2 machines on that particular platform. So it is 126 machines. It's not 254 this time, it is 126 machines that would be available per network. So in lab A, we can have the machines ranging from IP address dot 1 to dot 126. Okay, it would be 192.168.0.1 to 0.126. On lab B, we would be having the machines which are ranging from the values dot 129 onwards to dot 254. Okay, 255 is gone, 128 is gone. So this is how it is calculated and it works. But how is this number coming in? The number is coming in with this 1. If you keep it 0, okay, if I have a restriction that I want to keep it 0 for now and still I want to use it for the network part, so if this is 0, we have just 7 bits to play with, and 7 bits would range from 1 to 126. Okay, that's how it would work. Again, when it is switched from 0 to 1, in that case we have got 7 bits which would be taken along with the 1. So if you have all the bits 1 and this also 1, you will be having 255, which is the last IP address. So 255 would be used for broadcasting, so we don't use it directly. If I switch it to all ones and the last one to be 0, it would be 254. That's how we calculate the IP addresses. So IP addresses fall in the same pool, but still the machines will not be able to talk to one another because half of the machines would be using the subnet mask, which is this 255.255.255.128, and half of the machines would be using the subnet mask, which is dot 0. Alright, since subnet masks are different, they will not be able to talk to one another. Now what is this called? This is called a collision domain. Okay, so collision domains are present on the same network, but still they are not able to talk to one another. The devices that are used for creating collision domains are switches. We do not use hubs. Hubs are used to connect the machines within the same collision domain. So collision domains are separated by a device called switches. If there are multiple collision domains falling inside same section or same network, we could use a switch. But just in case, if you want to uh, separate out two different networks altogether, that means the network part should be different. Let's say I have a class B network and class C network, and I want to initiate communication between them. In that case, I need a specific protocol called NAT, and this is used by a device that can help us in connecting these two domains is router. Okay, and those two separate networks that we have created in two different classes is called broadcast domains. All right, so the networks which fall in two different classes or have two different network series are the broadcast domains. Even if your subnet masks are same, you will not be able to connect to them. So that's a specific that is a specific requirement for broadcast domains. If you are talking of collision domains, in that case your network part would be same, but your subnet masks are different. Okay, and there is a reverse stuff between a broadcast and collision domain. In collision, you have got different subnet masks, same network IP address. Here in broadcast, you have got different network IP addresses, and your subnets may or may not match. So it's not mandatory. So it's good to have knowledge. We wouldn't be worrying about this a lot. You don't, in day-to-day life, you wouldn't be required to set it up or even make the systems connected. What you would be required to do is to make the systems talk using DNS, using names, grant the systems their names, grant the systems their IP addresses. using DHCP. Okay, so this is what we are going to talk of um, this time. So before starting with that, I would need a few minutes to spin up the machines, and you could utilize that time to ask any of the questions or queries that you might have. So what I would be needing is a box, and we'll remove the others which are not required. Okay, how do you install a DNS, and what is DNS in first place? DNS is a service that helps us identify the machines with their names. So whenever you have a box, it has got two different attributes. One is called its host name, and another one is called a domain name. Domain name is the network's name to which that machine belongs. During authentication as well, you would be asked a domain name to which that machine would belong. Different domain names would be uh, authenticated differently. We could set it up. So let's say my host name is DNS and my domain name is example.com. So according to this, my FQDN, that means a fully qualified domain name, would be, anyone? Any guesses?
DNS:example.com. DNS.example.com.
Great. So it's dns.example.com. So where DNS part would be the subdomain, example.com is a domain, and the complete URI, whatever it is called a fully qualified domain name that would tell you which network and which system to talk to. And DNS uses FQDNs for identification of the machines over the network. So next time, even if my IP address would be something like this, 192.168.56.1, if that is the IP address that I'm giving to my DNS machine, I wouldn't be required to use that IP address every now and then to identify that box. I would just say go connect to dns.example.com. Or if my Jenkins machine is on IP address .2, I don't have to remember the IP address. And why do we use DNS in first place? We need a domain name service to help us identify the names and not the IP addresses. Now, in older days, when we didn't had mobile phones, we used to remember the numbers of our relatives, and it was a general practice, right? We used to remember that. So 10 numbers, 15 numbers, not a biggie. But if it became 100 numbers, what? That's a problem. But today, if you think that you can remember multiple IP addresses, well, that's the problem, right? We cannot remember at most 10 to 15 IP addresses or so. But you definitely know more than 100 websites, right? Every one of us does. So how is that possible? Because we relate the websites with their views and provide them with a name which is easily understandable and rememberable. So if we can remember that, okay, we don't have to remember the IP addresses. That's why DNS service is there in place. So that we don't have to remember the IP addresses. It resolves the fully qualified domain names to IP addresses and IP addresses back to fully qualified domain names. So it is called forward and reverse resolution. Forward resolution, in which your domain name or FQDN, I'll call it as FQDN, is converted to an IP address, and reverse is IP address to a FQDN. Okay, so let's see how to set it up. If you have the machines up in Asterisk class, we have created a box, right? So today I'm going to show you how to configure DNS on it. Log in into your machine. once you log in, you get you would get a prompt like this. And on this prompt, what you could do is type in sudo su. This is for the people who are new to the Linux boxes. Okay, so whenever you want to use the machine as an admin in Windows, whenever you install a package or a software, it would prompt you with a nice dialog box that you need to authenticate this or authorize this. All right. The same way in Linux, if you want to tell Linux that okay, I'm an admin, I want to proceed it according to that as well. So the same access rights would be provided to this software. So if you want to specify that, then you use the command sudo. Any of the command that you want to fire after it as an admin, so you could write sudo and your command. So apt-get update is a command that updates your source code repositories here, source code listings. And sudo tells us that I want to run this command as an administrator. If I don't do it, let's see. Apt-get update doesn't work. Okay, so it says unable to log the administration directory. If this is the error that you're getting, that means you need sudo to be used before that command. Then it would start working. Okay, but if you don't want to type in sudo every now and then, so what you could do is you could simply elevate your rights to super user. It would ask you for a password for the first time. Next time, if you see on console, it is root at the rate. So I'm not anymore my username. I'm not using this as my own user, but I'm using it as a root. And root could do anything, or an admin could do anything with the system. So next time you fire apt-get update, you don't have to use sudo this time. We'll wait for this to finish, and then we will be installing the packages for DNS. Setting up DNS is really easy. The package that we need is bind 9. So we have just updated our source code listing. That means what happens here is Ubuntu already knows where the softwares are kept online, and the people who are developing the softwares, who are committing different versions of it, publishing their packages, they usually keep on renaming the stuff, and most probably the URL might also change. So if that happens, your Linux machine or Ubuntu system or even RHEL or CentOS boxes, whatever you are using, they don't know where the newer packages would be kept. So all these lists are maintained by the public servers. So what you would be doing is you would be first updating your own data or own records, that okay, this software or this category of softwares would be placed at this particular URL or servers. I need to update the lists. And once you do it, next time you try to reach to that software, you'll be able to reach it. Otherwise, if the server changes, you will not be able to do. That's the reason why we first need to update our listings. If it's a long while, maybe a day, 7 days or so, you will have to apt-get update your systems. Well, how do I install? Apt-get install package 9. Sorry, bind 9 is the package name. I'm installing it. So that would be installing package bind 9. That's first step. Okay, what's the next step? So I'll create another machine, preferably I'll show you from scratch. So today we are not setting up operating systems. Yesterday we have set up the operating system completely, but today we are not required to do so. What we are going to do is just clone from that box, create a duplicate of it, and then use it. If you think I'm pacing up too much, or you're not getting all of the stuff that I'm talking of, please raise your hands or feel free to unmute and talk. Okay, I don't want anyone to be left off, because it really becomes tedious afterwards when you would go through the videos and try the stuff all by yourself and no one is there to explain how it's working. Okay, so this is a box where we would be trying to set up sudo su, type in your password. Okay, all set. Apt-get update. And if you want to combine two commands together, you could type in double ampersand. So I could say apt-get update and apt-get install forcefully the package bind 9. So wait for a minute. It should finish installing bind 9 package on this box, and we'll see how to configure it from scratch. Okay, almost done and finished. So we have got bind 9 installed. Okay, once you have bind 9 installed, um, what we need to do is, very first we need to set up the other utilities. Now bind 9 is the main package, but if you want to have some supporting utilities to be installed, what supporting utilities would be there is, if you want to check the configuration file before starting the service. Okay, if you want to check whether you have configured the different zone files properly, in that case you need different utilities to be installed. Also, that if you need man pages or manuals or documents to be downloaded, there are two more packages that you would be installing. It is apt-get install bind 9 utils and bind 9 doc. Bind 9 utils and bind 9 doc. So I'm installing that as well. Very first I need to mention that I want to set up the server in IPv4 version. Now this is the point where we are actually configuring it. Right now we have just installed the packages in default mode. This will not help us to resolve the IP addresses. Very first we need to make sure that it works in IPv4 category. So open up a file which is here at etc default bind. Okay, so the file name is etc default bind 9. You open it, and the options that you want to mention is -4 -4 -u bind. So it will start serving the DNS over IPv4 protocol. Save it. Now the default options file, whenever we want to resolve the IP addresses to the domains or domains to the IP addresses, we need to specify separate files in which the configuration would be stored. The relation, okay, that this domain or this FQDN should be qualified and this particular IP address should be written back if the request comes in. So the relations between your FQDN and your IP addresses are kept in files, and these files are called as zone files. Every separate domain or every separate network category would be acting as a separate domain, okay, or a separate zone. So how do you classify them? Very first thing, try to classify them as collision domains or broadcast domains. If they fall into two different broadcast domains, in that case you would be creating a separate zone file for them. Now in my case, I have a domain name called example.com that I'm using internally. So what I would be doing is, let me show you then example. All the configurations for bind9 are kept at this location at cbind, and here you would be looking at various files which are already present. The default configuration options are kept in the file called named.conf.local. Here you would be finding the zone entries. Okay, so very first thing is that we need to add a zone entry that I want to have this bind software resolving these particular um, domain names. So how do you add a zone entry? It's very simple. Very first thing, you type in zone, then type the name of your domain. So in my case it's example.com. So any machine that comes in like this, that abc.example.com or 123.example.com would be resolved using the file that I'm mentioning here. Okay, don't miss the semicolon at the end. Type is master. In DNS, there are multiple types that you could set up DNS with. It is a master. That means all the configuration files would be kept here. You could keep it as a secondary system where it would be pulling up the data from the master server first. You could also keep it as cached, where it would be just acting as a repeater of the values. Today we are going to look into the master type of server setup. So there are just two entries. One is type master, another one is the file where you would be keeping all the data. Since all the files are already being kept at this location, I would be keeping my zone files here as well. If you want them to be kept at some different location, you could give the different path. So in my case, the path is at cbind, and the zone files that I want to create, I would name is db.example.com. So you could name it anything. Why I'm typing in db? Because I want to follow the convention that these people are using. It's not mandatory to use db dot something. You could simply say abcd and it would also work. Extensions don't matter. Okay, if you have a secondary DNS server and you want to allow the transfer of settings from this machine to the other one, just in case, for your knowledge, you could write allow transfer to the separate machine which would have some IP address, maybe this. Do not forget the semicolons. We don't need it because we don't have those machines existing. So this is the simplest zone entry that you would be doing for forward resolution. Okay, for reverse resolution it's a bit different. We'll talk of reverse resolution in a while, but very first let's see how this works. We need to create a file db.example.com, but how are we going to create it? Very first thing, if you look at the folders listings, there are different db files which are already present. Now one of the files is called db.local. If you open that up, you would be looking at some entries. Now we could use this as a template. Okay, so you don't have to remember what has to be configured. Simply copy this into your own zone file and you're good to go. So what I'll do is I'll simply copy db.local as db.example.com, the new file that I want to create. And then I will edit my db.example.com file. Okay, now that was localhost. Okay, it was a localhost for a reason, and that's why all these entries which are here inside this zone file configuration is actually localhost. I would be changing it to my domain, which is example.com, right? So it says root.localhost. Let's change it again. It is root.example.com. Again, your name server IP address. So your name server is dns.example.com. The server which provides you with DNS service, it's called a name server. The IP address of it, give it some IP address. The IP address of this machine, okay, .56.1, whatever the IP address is. And at last, you would be adding an entry. Now there are different kinds of records that you would be adding in here. One of the records that you're looking at is a record or an address record. Yet another is AA, which is address records for IPv6 type. Okay, then there is NS record, which is your name server record. There are many more. You would be looking at CNAME, which is canonical name. The use case for canonical name is that whenever you see some shared hostings, there would be one single machine on which multiple websites are hosted. Now all these websites are hosted using canonical names or CNAMEs. Okay. Then there would be MX records or mail server exchange records are there. Then there is SOA, which would be giving you the different attributes on which your records are transferred in the network. So there would be your TTL values, your expiry values which are there, your refresh duration when the system should connect back to this DNS to get the refreshed value of that particular IP address. So it might happen that your DNS would take time to resolve these things. Maybe if you have ever worked with shared hostings, the people who are setting up the websites for you would tell you that it would take almost 24 hours for the DNS IP address to resolve to your particular website. Okay, so that was in earlier days, but now it becomes it is done very fast because the TTL values are kept very low in that case. So what happens is, if I have a website and the website was first being hosted on IP address maybe point 0.1, next time something went wrong with point 0.1 server and I want to host it on point 0.2, so you could host it as soon as possible. But regarding the other people who still are accessing your machine not from the IP address but using their own domain names, so the domain name would be same. You wouldn't be changing your website's domain altogether. So what you would be doing is you would be switching the entries in DNS. But DNS, the initial entry was set to refresh after a day, okay, after maybe 86400 seconds. In that case, what happens? Your client machine will not know that your existing system has changed, and it would be using the same IP address for connecting back. And that would create a problem because your website has moved and the client doesn't know. So what is the solution for this is you need to change the TTL values in the DNS and the refresh duration as well, so that people can get refreshed and latest DNS data. What is trade-off of it? DNS server load would increase. People would be pinging back DNS every now and then. Okay, so now what about the other machines on the domain, and why I have written only DNS and not complete FQDN, dns.example.com. I have written DNS because any of the domains that you are specifying the zone file to be in, which is example.com in my case, in that the example.com would be appended after the initial names that I am typing in. So if I write something like node1, it would automatically be appended by example.com. So it would be node1.example.com. If I don't want that to be appended, in that case I would be adding a dot after it. That means the name is absolute. You don't have to add anything after it. And the A record, that means the IP address where it belongs. It is belonging to maybe some IP address. That is forward resolution, but does it work? For that, restart the service. Remember the names of the utilities that we have just installed the package of utilities, right? Bind9 utils. So these utils are these utils. So the names would be named. I would be checking the zone file, check zone example.com, and the file name is db.example.com. So we'll check whether it works. It says okay. That means there is no error in it. Restart the service. Service bind9 restart. Okay. If everything works, in that case we should be able to resolve the IP address. For that to work on the client sides, we will have to change the result.conf entry. And one of the entries should say that the name server exists at 56.1. If the name server entries do not exist here, the machine would never know where to connect in order to resolve the DNS. Okay, let me check what is the IP address here. It is actually 56.60, so we'll have to change it accordingly. 56.60 here. Go back to db.example.com and change the entries here as well. So my DNS works on .60. DNS doesn't check um, whether the machine is up or not. It would just provide you with an IP address. It's your headache to check whether the machine is up or not. The command for checking DNS is nslookup. nslookup on what is one of the entries that we have added. We have added dns.example.com. So it is resolving back to 56.60. What about node1.example.com? It is resolving properly to 56.2. This is an example of forward resolution, but we want to resolve it back. Okay, in that case it is called reverse resolution. How to add a zone entry for that? To add a zone entry for reverse resolution, we need to look at another file, and that file is called db.127. Like we have copied the file db.local first, this time we are going to copy the file db.127. The entries are pretty much very similar, but on the left hand side, instead of providing a name, we have IP addresses, and on the right hand side we have the names, just opposite. And these records are called pointer records. See, when your IP addresses points back to its FQDN, that record is called pointer record or PTR record. And here only three different classes of your IP address are provided. Now it depends on how many classes of network you are having. Okay, since 127 network starts with one single network area and other ones are just hosts, these may, let me show you the entry first so that the ideas are clear. Name.conf.local would be holding all your zone values. It is very much similar that a zone example.com, whatever we write in here would be appended to that particular domain name in forward resolution. So whatever I write as zone entry for reverse resolution would be appended to that IP address. Okay, makes sense. So if I have a IP address of class C, which is having three different network areas and one octet reserved for the hosts, I would be writing something like this. My network starts with it is 192.168.56 dot something, so I would be writing 56.168.192, just in reverse. Okay, domain names are resolved from the extension first, then the domains, then the subdomains. So they are not resolved forward to back, they are resolved from back onwards to forward. Okay, that's the reason we are also reversing the IP address here. It is 56.198.192.in address ARPA. So what would be appended? 56.198.192 would be appended to your IP address. whatever you are adding there. Do not miss the semicolon. Again, the type is master, and the file where all your entries should be kept would be at some location that you specify. So I'm specifying bind, and my file name would be db.192. Okay, because that's the network part that I'm using. You could name it anything. So that's your zone entry for reverse resolution. You could change your IP address according to that, it would switch. Okay, I'm using class C, so instead of using two different octets in the file, I will be placing only one octet. So what I need to do next, copy the file db.127 with the name db.192 because that's the name I have written in the configuration file, and start editing db.192. Okay, what has to change? Very first, localhost changes to example.com. Alright, my name server is not localhost now, it is dns.example.com, and the IP address. Now these are three octets. These are three octets for a reason, because 127 has got one network part which would be added to its zone entry, and there would be three host parts which would be specified here. In our case, three network parts have already been uh, clearly mentioned in the zone entry, so we need only one last part to be specified. So the IP address that would be created from this would be 192.168.56.1. If you have written something like this, and there would be two network parts, just for an example, so the IP address would be read like this: 192.168.0.1, not 1.0. It is again reversed. Okay, and what is our machine name? It is dns.example.com, and it is not on 1, it is on 60. To ensure the correctness of these IP address is your responsibility. Okay, if you type in the wrong IP address here, it would resolve to a wrong IP address. It does not check for the validity of that IP address. And now here, if you see, we have added a dot after the names. That means the names are absolute. Nothing has to be appended after it. But with case of IP addresses, we are not placing the dot, so the network part would be appended to it automatically. For the another machine, which is 2, so I would say in ptr record, it should be node1.example.com and dot again. You could add as many entries as you want after it. Save it, check service by 9, restart. If everything is okay, it would restart successfully, and we should be able to do ns lookup using the IP addresses now. It resolves to node 1. If I type in 60, it would resolve successfully to DNS. Okay, that's how we don't worry about any of these machines. So if I am doing a ping, I don't need to specify the IP address. What I would be doing is I would just specify dns.example.com, and that works. So any of the functions that work on the network would be having internal logic to convert your domain names to IP addresses first. Like in Python, the function name is get addr info, get address info, or get host name in get host name and get host address in PHP. The different languages would be having their own different functions to resolve domain names to IP address and IP addresses back to domain names. One such setup I've already done on my network. I'm shutting down this box for now. So this DNS machine, in my case, let me show you. Let's bind named .conv.local. I've got multiple zone entries. So I've got two different zone entries for forward resolution and one for reverse resolution, exactly the same way that we have configured it now. What about the files? So the files for forward resolution would look like this: bind db.example.com. The only difference is that I've got multiple servers assigned here. There are multiple IP addresses. We have just played with two different IP addresses in the example that we have set up. Another one would be a server which is called DHCP. Okay, any doubts about DNS? We have went into it pretty much in detail, okay, and very slow. So before jumping to the next topic, which is DHCP, or which is Dynamic Host Configuration Protocol, I'll tell you what the meanings of it is. Do you have any queries or doubts on DNS side, so that we can move ahead? I would be using this all across the projects. So whatever we are learning, we are going to put into practice in the coming classes. So it's not that we have learned it and you are free to forget it. No. Next time I need it, I would be simply using it with configuration. All right. I will not be setting it up again from scratch. So when we set up our SVN and Git servers, we will need the DNS help again. We would also need the help from DHCP. Until now, you are using the DHCP which is provided by your VirtualBox. We would soon be giving up on it and we would be using our own DHCP servers. Any queries or doubts? Okay, so let's start with the new topic which is called DHCP. Well, asking questions and responding back is the only way to tell me that you have understood or you have not understood. I would take it on a positive side that you did and believe you for the next coming classes. All right, so it's DHCP time now, and we would be setting up another server which is called DHCP or Dynamic Host Configuration Protocol. Why do we use it? You all know that there would be two types of IP address assignments happening. One is static IP addresses, another one is dynamic IP addresses. What does it mean? Static IP addresses are the IP addresses which are bound to that particular machine. If the machine goes off the network, you will not be assigning that IP address to any other box. Whenever the machine comes back, the IP address would be visible on the network. Okay, so it is bound by that physical box. It's called static IP address. IP addresses are generally bound to the NIC cards or NIC cards, Network Interface Communication Card, which would be helping you to connect to that particular network. So and the another class is the DHCP, or which is provided by DHCP or dynamic IP addresses. Now these IP addresses are a pool of IP addresses that anyone can use. If I want to connect to a network, the IP address would be automatically assigned to me. These IP addresses are not bound to be attached to any of the system or machine or NIC card. It can be assigned to anyone else. As soon as I go off the network, if someone else joins and the IP address is now free, he would be given that IP address. So machine keeps on switching the IP addresses. If you're using the IP address for some identification purpose, or you want to set it up in DNS, you cannot rely on a dynamically changing IP address. You can only rely on a statically bound IP address in that case. So how do we set up DHCP? For setting up DHCP, we again need to do the same thing. Sudo su. I'm logged in as a root, and now I need to install a package. A server server DHCP would be installed in package called as ISC DHCP server. Okay, so this is the package that we need, and we would be configuring that package soon. install it. Providing IP addresses is not the only use of DHCP server. It is a host configuration protocol, so you could configure pretty much all the initial level of uh, network configurations that are required for the machine to be connected to the network. Like you could use DHCP to provide the records where your initial boot records are kept, like in case of PXE environments. Okay, PXE provides you a way of installing operating system over network. If you don't know that, so DHCP can help it. DHCP can also give you your subnet mask. It can tell you where the gateways are. It can also tell you where the name server is, which name server to use. Okay, so everything can be configured in a DHCP, and we would be configuring just that. So how to set up the DHCP server now? I have already installed it. The file that you would be uh, using for setting up all these configurations is etc dhcp dhcpd.conf. DHCPD is the daemon. So daemon configuration we are supposed to be changing now. Okay, now this is the file for your perusal, and you would be changing anything and everything that you need in your domain. Okay, so let's change it. First things, my domain name. My domain name is example.com. Okay, where does my domain server reside? My domain server is on the IP address 192.168.56.1. You would also place the complete domain name. But the reason why I'm not placing a complete domain name is that if my domain server is not properly configured initially on any of the client, it will not be able to uh, maybe ping it back. Or if something is wrong with the domain name server, I can still reach it via IP address. But if the service is down, in that case, I will not be able to resolve the names. So it's always a good idea to place domain name servers as an IP address instead of the FQDN. Okay, what's next? Next part is to assign a range of IP address to the network, and this is the block that would help you do that. The block is on line number 53 onwards. So what I'll say is I will simply uncomment everything. We don't need to write anything here, just modify the entries which are already present.
uh, like if we set up the DHCP server, the use of like does it gives the IP addresses to the other servers?
Yes, the
Like
other servers would be requesting the IP address on the network, and DHCP would be the one to provide that.
okay, means the other servers which we have like Ubuntu for 14.04, like this DHCP server will giving the addresses to other servers.
Right. Yes, it would.
Okay.
I'll give you an example of it as well, that the server would be requesting an IP address, and unless and until your DHCP is up, your servers cannot configure the IP addresses themselves.
Okay, means it is providing default IP addresses to the servers which we are configuring.
Yes, it would.
Okay.
Okay, so let's see how to set up. What is your network? Network is 192.168.56.0, and your net mask that I'm using currently is 255.255.255.0, which is the default IP address of class C. No, default subnet mask of class C. The range of IP addresses that I want this server to be providing is 192.168.56.50 onwards to so the first system that would be requesting the IP address would be getting the IP address .50. Another one dot 56 dot I say 190. So the complete range of IP addresses which the DHCP server is able to provide is from .50 onwards to .190, a total of 141 servers. Let's change other stuff. Domain name servers are again, I don't want to specify the name, I am specifying the IP address. Okay. Optional domain
Like
name.
every time we log in, like our IP address changes, right? Do we have to do all this process every time we log in?
No, this is
Like
one
the
time.
IP. Okay.
This is one time
Because
configuration. Yeah, go on, go on.
like if 192.160 dot last time it was like I if we do if config it was 56.60,
Hmm.
like once we shut down and restart it might be the different IP, right?
Well, for that, I'll show you how I have configured the stuff. Okay, so we are all set to go with it. Okay, your broadcast address, your routers, that means your gateways, your domain name servers, the range which you want to assign. Now the server on which you'd be setting up your DNS should be having a static IP address. It should not borrow the IP address from DHCP. That's the reason why we have started the range from 50 onwards. So what we say is that all the IP addresses which are below 50, I would be manually assigning them to the machines. And anything new which is coming in the network should be getting the IP address from the DHCP. So how to set up your static IP address? Let me show you. In etc network interfaces in Ubuntu. If you're working on CentOS boxes, it would be etc sysconfig/network scripts. Okay, here you can set up the protocol on the particular network, a particular NIC card using which it should be taking the IP address. So my ETH1 is taking it from the DHCP. I could change it to static. In that case, it will not pull the data from the DHCP. It would have its own address. Okay, and the IP address in that case I want 192.168.56.1. So this is what I have done on my DNS machine. I'll show you shortly. So the DNS machine does not borrow the IP address from the DHCP anymore. It has got its own stable IP address. The IP address is stable, you could restart the machine multiple times, but even then you'd be getting the same IP address, so you don't have to configure it again and again.
Okay.
So after you configure your DHCP, there is a service restart required. Service IHC DHCP server restart. Okay, so the server is now restarted. If you spin up any new machine in the network, you would be getting the new IP address. Well, let's see. I have got this set up in place. I'll just give you a demo of it. So this DNS box that I have has the configuration like this: DHCP dhcpd.conf, the same configuration, but here the range starts from 50 to 150. The newer machines that I would be spinning up, let me shut it down. So very first, service ISC DHCP server, I'm going to stop it. Okay, so the new machine, anything that I'm spinning up in this network, let's start one of the box. Okay, so I'm starting this machine. This machine is configured to be attached to a host only adapter on adapter 2. Your DNS services are off in the network. Not DNS, the DHCP services are off. So when this machine tries to pick up the network configurations, it would just wait for getting an IP address because it is set up to pick up the IP address from DHCP. Now it says it is waiting for network configuration. It would still wait till we finish off with the configuration. So what I'll do is I'll bring up my machine. So on the DNS side, what we would do is I would start the service now. Start. As soon as I start it, the machine should be able to pick up the IP address and it continues with its boot. Okay, so that's how it would work. If you have a static IP address setup, then in that case you don't need DHCP server. So on my DNS machine on the left hand side, I have set up the static IP address, network interfaces. So if you see, the address of this machine, which is set up on ETH1, is static. It's not a dynamic IP address. So the static IP address is set to 56.1, netmask is 255.0, so I could trust on it because it is not going to change. And I can have all my client machines to point to this box, which is my DNS box by default. If I'm running my own DHCP server, in that case, you can shut down the server, which is provided by your providers. So I could go here, host only adapters on ETH1 that I'm using. DHCP server is disabled. I have not enabled it. I want to disable it for a while because I'm using my own DHCP server in place. That also means that anytime you want to spin any other new machine, you need DNS server to be up always. Okay, because without your DHCP, other machines will not be able to configure their ATH ports. All right, so today we have learned about DNS and DHCP. Um, we have good 6 minutes to go again. Any queries or doubts are welcome. I'm here to answer those queries for you. In tomorrow's class, we would be learning more on infrastructure servers. So we will see about Apache, Nginx, what are the trade-offs of using one over another, when do we use one of these architectures. Okay, that's what we are going to discuss tomorrow. We will also start with Subversion and Git. Okay, so we'll cover Subversion and Git in tomorrow's class. How to set up Subversion on the server side, how to set up Git on the server side, how to get it running on the client machines as well. Okay, so you would be needing help on we would be needing help from DHCP servers as well as the DNS servers. We would be setting up the entries there. So that's about the coming classes. What I expect from you guys is that you come prepared so that you can quickly relate to what's happening in the class and you could ask more targeted questions. Anything that I can help you with? Any queries or doubts?
Yeah, hi, Ahish. This is Murli, and today is my first class. So, like, as a DevOps engineer, like this DNS and DHCP will be done by some or like this will be taking care of a networking, like what exactly?
No, we wouldn't. In most of the cases, DNS and DHCP would be configured by ops team, and DevOps
Okay,
people will not be bothered about it. DevOps people would be only related to the automation side of the complete infrastructure. So you'd
okay,
be setting up the servers, you'd be configuring them to work with one another. Configuration
yeah,
management systems like Puppet or Chef, setting up the CI/CD pipeline is what the task is. But it is a good to know knowledge that everyone should know as preliminary basics. That's why we are taking it up.
yeah, got it. Thanks. That's
So we are not acting as a system admin, just to be very clear.
yeah. Just I want to know that what exactly that's it. So, like, I have missed like one class. Like, what, like, when can I expect that class by?
You would be getting that recording, or
Mhm.
if you're not able to pick up the things from there, we can arrange a separate class for you guys.
Okay, thanks.
Any more questions? People who are new to Linux, are you able to relate what's happening here? Because I want you guys to practice it at least once or twice.
Yeah, like I am Murli once again. Like I have experience on like I work for the I worked as a web peer admin server like in India like 4 years. So I worked as a middleware for Wipro in Citibank.
Hmm.
So like I only worked on like server. I only worked for like WebSphere app as a WebSphere application server only as a on only one server like as a middleware. So this is like kind of club. So like what exactly these like it will be including all these server side, simple web servers, web sphere, and web logic, all these also they will be including for these. These all admin activities will also come under this DevOps, correct?
Yeah. So if there are no queries coming up, it would be well, it would be good idea to drop off the call. So you'd be finishing it off in next 2 minutes, and we'll meet again at 8 a.m. IST with the new topics, which is Subversion and Git. And if time permits, we'll also start with Apache and Nginx servers. So what to expect from tomorrow's class is that we would be setting up the server-side Subversion and Git. We would be playing up with them. We will also set up Jenkins integration. Okay, so what I believe is we would be taking smaller steps. Okay, so Jenkins would be spread across different multiple classes. As and when we get some tools to integrate with it, we would be integrating it and learning the deeper aspect of it. Okay, it's not that we would be holding on one tool and finishing it off in the very first class. That's not a good idea. We'll keep up with it one step at a time. Like we have covered DNS today, but we would be using it all through the class. Okay, same with DHCP, same with SVN and Git, same would be with Jenkins, and the similar stuff would be done with Puppet. So you don't forget about the stuff till we reach the end of the class. So that's all from my side for today. I hope you have a great day ahead. We'll talk again tomorrow 8 a.m. in the morning. Thank you so much.